Good morning, good afternoon, and good evening, and welcome to the Friday Talk Show with Global Electronics and your host Rajiv Kulkarni. Every Friday, we bring in this 30-minute show to educate, to create awareness in the electronics manufacturing sector, manufacturing industry, and segment where the process engineers, the design engineers, the manufacturing engineers, and the supply chain people and the marketing and the sales people can get some information from our veteran industry expert, the technology expert who have served the electronics industry for decades. And there are possibilities that the young generation also can participate and share their experiences in the present electronics manufacturing industry, what's happening, and that way the others can get benefit out of it. And today's show is a very important show because it's one of the key element that we bring in the electronics manufacturing, and it's one of the very key, I would say, the point where the products after assembly of the components on the printed circuit boards being inspected. So in other words, I would say in PCBA, that is printed circuit board assembly line, the AOI, that is Automatic Optical Inspection, in short AOI, has become a critical quality gauge in modern electronics manufacturing. And as we all know, the complexity of the PCB design, the complexity and the miniaturization of the PCB and higher quality expectations, AOI is no longer is just a defect detection tool. It is a key process control for yield improvement and smart manufacturing. And to discuss the importance of AOI in PCBA, we have Mr. Siraj Puthanpurayil, who is a senior technology expert in India. And Siraj comes from a background of more than 4 decades in the electronics manufacturing itself. And he has been serving the industry in India, and also he has served for major corporations. And he is a result-oriented or result-driven manufacturing leader, as I mentioned, with more than 4 decades in the PCBA experience and automation and quality excellence, and across multiple or multi-plant setups. I have met him, I have experienced working with him, and he is a great person. He's a great, highly technical driven individual, and he is passionate about industrial transformation and standardization and empowering the next gen talent. Ladies and gentlemen, let's welcome Mr. Siraj. Siraj, good evening. How are you this evening?
Good evening, Mr. Raji. Thank you for your brief introduction. Feeling really great about your introduction. Okay,
Thank
great.
you, sir. Thank you.
Thank you. And
Actually,
I want to thank you for giving me an opportunity to talk about AOE today.
yes. In fact, since you have a lot of experience in working on the PCBA line, where I have seen practically and physically, I have met you in your facility. And so that definitely is a big plus point to bring you on the show today, so that your wealth of experience, the wealth of knowledge in the electronics manufacturing can be shared, and so that it can benefit the people, the engineers out there who are working on a day-to-day basis in the process engineering. So I'm pretty sure you have some slides to share, and you can just go ahead and start presenting your slides. The stage is yours.
Thank you, Raji, once again, giving this opportunity. I think my screen is visible to you, right?
Yes, it is.
Yeah. So once again, good morning, good afternoon, and good evening, everyone. Thank you for joining today's session on automated optical inspection. And across electronics manufacturing, one common challenge unites us: how do we detect defects early, consistently, and without human bias? Before we go through the session, let me clarify one thing. AI is not just a machine that finds defects. When implemented correctly, it becomes both a quality gate and powerful process improvement tool. During my visit to many EMS and OEM plants, I have noticed that average first pass yield of AOI is less than 90% in most of the industries. Even in some industry, it's running with around 50 to 60%. It means that every 10 board produce, every 100 board produce around 42, more than 40 boards are defective. So this is the big challenges. To bridge this gap, what is the major gap? The expertise of engineer to fix the issues. So I'm hosting this lesson as a learning series on AOE, covering AOE fundamentals, how AOE works, challenges and best practices, and AOE in the bigger future, that is AI-driven AOE, designed for maintenance, quality engineers, and production supervisors who want both conceptual clarity and practical insight. Is it clear?
Yes. Continue. Can continue.
Okay. So inspection is a critical quality verification step in the PCB assembly process because it ensures that every component placed correctly and soldered properly before the product moves forward. As product become more complex and components continue to shrink in size, manual inspection is no longer sufficient or reliable at all. In addition, the test coverage is often limited because there are a lot of passive components like connectors and some metallic parts which cannot be tested in ICTs, and that make inspection is essential to prevent a defective board from escape into the field or maybe to the customer itself. So effective inspection reduces the rework, customer return and field failures while protecting overall product quality and cost. So what are the challenges with the manual inspections? Manual inspection is still used in low volume or prototype build, but it comes with the several limitations that directly impact quality and consistency. First, manual inspection is highly dependent on the inspector skill, experience, and focus. Fatigue or distraction can easily lead to the missed defect, especially on dense or complex PCBAs. Second is that detection capability is limited, especially some small components like O201, O402, or lesser than that, or QFN, fine pitch, are extremely difficult, if not impossible, to inspect reliable within the naked eye. So manual inspection also suffer from low repeatability and reproducibility, meaning the same board may be judged differently by a different inspector. Finally, it is difficult to identify systematic defect pattern, maintain consistent documentation, and ensure traceability, making effective root cause analysis also a challenge. These challenges are the key reason why automated inspection become essential in modern PCBA manufacturing. Next is the AOE as a PCBA test strategy. So AOE is not just an inspection machine. It is a process control used to monitor both the assembly and through-hole assembly process. In many industries, AOE is a part of the overall PCBA test strategy because some to ensure that each and every component are covered during the test, it cannot be guaranteed in ICT. So AOE is taking that part. AO works as a Jidoka tool also because it detects a problem automatically and stop defect from moving to the next stage. The main objective of AO is to ensure PPSP. You might have heard this view, it's new. Presence, polarity, soldering, and value of the component so that product functions correctly for the customer. By detecting issue early, AO helps to detect, correct, prevent defect in real time. That's advantage. Compared to manual inspection, the AO is faster, more consistent, and capable of inspecting complex and densely populated PCBAs. Overall, AO ensures repeatability, traceable quality, and strong support for the organization to ensure zero defect vision. So, where AO fit in the PCB assembly flow? AO is strategically placed at multiple stages in the assembly flow. That is at the pre-reflow AOI. It detects placement and polarity and the presence before soldering. And post-reflow AOI verifies solder joint quality and component integrity after reflow. And pre-wave AOI ensures correct component insertion before wave soldering. Post-wave AOI inspects solder fillet, bridge, and missing leads on connectors after wave. And of course, after the conformal coating also, we will be able to inspect thoroughly about the coating coverages and thickness. So by positioning AOI at a critical process step, defects are caught early, and rework is minimized, and overall first pass yield and product quality will be improved. So let us discuss what are the direct advantage of pre-reflow AOI. So it benefit on early detection of placement errors, prevent expensive post-reflow rework and work in progress at post-reflow. When we have a lot of rework, it will end up with accumulation of the PCBAs. Avoid components damage caused during rework process. It naturally used to happen. If not skilled operator do the repair means board will be damaged. Improve first pass yield. And it direct feedback to pick and place machine. There are options are available to directly interact and do the corrections internally, closed loop control. And the correction is very simple because just reposition or realignment. And operator skill depends on nothing. Any minimum trained operator can do job. And it complements SP and post-reflow OE by giving direct feedback. Advantage of post-reflow OE, verification of solder joint quality, fillet formation, detect solder bridge, no solder, identify cold solder, non-wetting, solder balls, icicle, tombstone, etc., verify compound position after soldering. Automotive and some industry, it's a mandatory to have the post-reflow OE, so it's a mandatory compliance. And of course, the traceability through MES. This is the direct advantage of the post-reflow OE. The key idea behind AOI placement is very simple. Prevention is always better than validation. That is why we look at pre-reflow AOI and post-reflow AOI differently. Pre-reflow is mainly about preventing defect from getting soldered, while post-reflow AOI is about validating the final solder joint quality as per the IPC or whatever the standard we follow that. So let us walk through the comparison table. Placement and polarity defects. So before the reflow itself, AO is extremely effective in catching placement errors and polarity issues. If we miss these here, they become expensive rework after soldering. Pre-reflow OI cannot see solder-related defect. That is why we rely on the post-reflow OI to detect no solder, bridge, tombstone, reflow-induced issues. The real power of pre-reflow is early preventions. Fixing a placement issue before reflow, it costs almost nothing compared to fixing it after soldering. Okay. If you look at coverage, pre-reflow is typically covers 60 to 75% of the defects, and post-reflow it covers 85 to 95%. That is why two are complementary to each other. If you have both, you can ensure that the total control of the defects. So many factories, they added pre-reflow and post-reflow. They observe that consistently that the defects has reduced by 30 to 50%, and that is helping to reduce the reverse reduction, better first pass, and mildly defects are completely stopped at the source itself. Okay. Now coming to the pre-wave AOI. In TSC as AO assembly, AOI can be effectively used both before and after wave soldering, with each stage serving a different purpose. Pre-wave AOI focus on prevention. It detects missing or wrong components, polarity, orientation errors, bend or short leads, and verify lead protrusion also. By catching workmanship effort before soldering, it prevents rework and all operator-related errors. And when we do rework, there are chances of pad damages, thermal stress, and it may impact on the functionality of the PCB itself. Okay, so advantage of the positive flow AOI, it's a proper validation, like as per the IPC standard, it validates everything is perfect, fillet is okay, component pushed properly, lead solder coverage, and it is acting as a final quality gate before testing and coating. In terms of coverage perspective, typically pre-wave AOI covers about 50 to 60%, 65% of TH-related visual defects, while post-wave AOI cover 80 to 90%. Used together, they provide strong defect containment and traceability in the PCBA assembly process. Now, coming to the conformal coating inspection. After conformal coating, inspection become extremely good because defects are no longer visible or repair easily. Because there are different type of coating. One is a transparent coating, and some is you can see UV. If it is transparent, it is very difficult to detect by the operator. So AOI or AC, normally called as AC also, automated conformal coating inspection. It ensures complete coating coverages and thickness on all required areas. Also confirming no coating on restricted areas such as connectors, test pads, switches, and heat sinks. It reliably detects coating defects like insufficient or missing coating, bubbles, whatever the coating related defects, able to identify or able to detect by the conformal coating ACI. Compared to manual inspection, automated CC inspection offer high repeatability, and we are able to measure the thickness wherever we want and ensure that keep out areas well protected and full traceability. It also eliminated operator exposure to hazard. There's a big challenges, when operators inspecting immediately after the coating, there are high chance to have a little bit of exposure of the fumes, and ACA is able to detect the final quality inspection also. The equipments are capable for that, and we can eliminate final quality inspection also by deploying the ACI. So it will prevent, because conformal coating is doing after complete test. So we can, if you do complete inspection there, you can completely eliminate any latent failures, and it helps to meet the stringent automotive or defense and other industrial audit requirement as well. So next, coming to the AOI technology. Before we discuss further into AOI technology, it is very important to align the expectation. What AOI mean to do that? What is not meant to do with AOI? This is normally the question will come that whether AOI can completely solve our issue. No. AOI is essentially a vision-based automated inspection system used in PCB assembly. It identifies and classifies visual defects in fast, repeatable, and consistent manner. No doubt on that. Unlike manual inspection, AOI does not get tired, does not vary from person to person, and apply the same inspection logic every time. AOI also acts as a critical quality gate in PCB assembly process. Beyond inspection, it is a data-driven tool. It helps us to understand defect trend, enable traceability, and provides valuable feedback to upstream process like printing and placement. It is particularly effective in detecting component presence, polarity, alignment, solder quality, and cosmetic issues. Whereas, where AI is not a non-visual inspection technology, it does not replace X-ray, ICT, or functional testing. Each of these tools serves a different purpose. AI is also not a plug and play or a fully autonomous solution. The good result from AOI depend heavily on proper programming, fine-tuning, and continuous optimization of the program. It is not a single solution for all defect type, and it cannot replace good upstream process in controlling the printing and placement or reform, because that has to be done separately. Finally, AI is not a complete substitute for human judgment. Sometimes, like there is a false code or something is happening, a review by engineers, verification, and engineering decision are still may be required in certain cases until we get fine-tuned. Now, let us discuss about technologies that broadly classified or utilized for the inspection. There are 2D and 3D technologies available for the AOI inspection. 2D AOI works by capturing grayscale or RGB image of the PCB and applying rule-based algorithm to analyze those images. The system compares image patterns, brightness, contrast, and shape against predefined inspection rules. In simple terms, it inspects what it can see based on how we teach it. 2D AOI primarily used to detect component presence or absence, offsets, polarity errors, and OCR OCB, that is optical character recognition or optical character validation also. So these value-based related visual check also possible in the both 2D, but 2D integrated with 3D integrated with 2D. It also effective in detecting the visual solder related issues, that is insufficient solder bridges, cued component, irregular paste deposit, and cosmetic defect also when we program properly. Since it does not have true 3D measurement capability, it cannot quantify the coplanarity or solder volume, because defect detection is based on image comparison. Okay, what are the image it capture it, and user defined rules. The performance of 2DA can be influenced by how inspection threshold are set, how lighting is configured, and how consistently the rule are maintained. That is why proper programming and tuning are critical for stable result in 2D AOI or 3D AOI. Coming to 3D AOI, let us now look at how it works and how it addresses some of the key limitation, key imaging possibilities. Okay, this is basically a image-based inspection, but it overcomes the limitation what is there with the 2D also. And it applies very structured light techniques such as Mori projections, all might have learned about it, to perform true three-dimensional measurement of solder joint. Instead of only analyzing the image, the system measures the actual height and shape of the solder joint. This enables accurate measurement of solder joint height, volume, and making it very effective for detecting insufficient solder, excess solder, and inconsistent solder deposit, and that type of issues. 3D also measures coplanarity of component bodies and leads, which allow reliable detection of defects like tombstoning and lifted bodies and lead in-on contacts. All this can be detected with the 3D. 3D is especially valuable for fine pitch component because very difficult to identify using the 2D, and QFN packages, high density assembly, and of course after that the process control of complete assembly line using this result what we got it from the inspection system. There is a drawback also in the 3D AOI. It is the shadow effect. Okay, why the shadow effect is happening? There are the limitation. What actually is that one common challenge in the 3D inspection is this is the shadow effect. The shadow effect occurs when a tall component or densely populated component block the projected light, creating shadowed region on the PCBA. This is especially common on high density PCBAs or when smaller components are placed closer to the taller component. Okay, in this shadowed area, the system may not receive sufficient reflected light, which can impact the accuracy of or height or volume measurement. Of course, the image here. You can see the illustrate how often light will get blocked it and resulting shadow and what effort the 3D reconstruction. To overcome this, the modern 3D AOS system uses multi-projection mechanism, typically 2 or 4-way projections. By projecting structure by multiple angles, the system ensures that the area shadowed from one direction are illuminated from another directions. At each pixel, the system evaluates the visual index and automatically select the image data with highest quality from multiple projections. This significantly reduces the shadow and specular effect and improve measurement reliability. So while the shadow effect is known limitation for 3D OE, advanced multi-projection design effectively minimizes its impact in real production environment. What it?
Yes, Mr. Siraj, I think we are almost through the time. I think you need to also go out of town. I guess the time is almost, coming closer.
I can finish it.
So,
it's only
okay, you can? Okay,
yes.
Okay. Please.
Okay. So this slide shows, just see this slide shows how 3D OA combine the strength of both 2D and 3D inspection. Some defects are best detected visually using the 2D images. You can see here the list. While other require true height measurement and volume measurement provided by 3D. Defects related to the component presence, polarity, marking, and OCV are effectively covered using the 3D images. Defects such as coplanarity issues, lifted lead, tombstone, solder volume, and solder fillet quality are much more reliably detected using the 3D images. That's why modern 3D OS systems do not replace 2D. They integrate both approach and automatically apply the most effective inspection method for each type of defect. In short, 3D OA provide a wider defect coverage with a higher confidence, especially for complex and high density assemblies. So here I'll discuss the inspection capabilities. This is summarizing the core inspection capability of both AOE, both SMT, TST, and conformal coating. AOE can reliably detect dimensional deviations, rotation, offset error, missing or upside down components, and lead compatibility. All these type of defects can be detected. From solder perspective, AOE is effectively in identifying insufficient or excess solder, solder fillet quality, bridging, billboarding, and non-solder condition. AOE also support OCV and OCR, which enable verification of component marking, part value, traceability, something that traditional inspection often struggle with it. All can be done with the AOE. All this capability allow early defect detection, consistent objective inspection, and significantly improve the first pass yield, preventing defect escape to downstream. Next process like ICT, function test, or even in the customer side, it will get prevented for that. Okay. Now let us come to the concluding. The real value of AOE lies in the dual role. First, AOE acts as a quality gate because it detects, it stops. It prevents defective board from moving to the next stage and protecting downstream stations like ICT, functional text, and customer itself. At the same time, OE works as a process monitor by continuously collecting inspection data and converting it into an actionable insights. With real-time monitoring, analytical dashboards, and drill-down capability, AOE helps us to track first pass yield, cycle time, defect trends, and fast root cause analysis because we get a problem immediately. And of course, the continued improvements like improving the OE, improving the first pass yield, everything. In short, AOE does not just stop the board here, but it improves the overall process in the PCBA assembly process and create good board. This slide shows how the AOE moves beyond the inspection and act as a real-time process monitoring system. Through real-time dashboard, we can monitor machine status, throughput, first pass yield, defect trend across different lines and different product line. With yield analysis, AOE can help AO data help to identify variation in the process before they become major quality issues. And by linking AOE result with SPA data, we can trace defect back to the root cause and fix even the SPA problem also. Even the stencil printing problem can be fixed by linking with the SPI. Finally, when we do the program, when you do the offline program, we can use this historical production data to fine tune the inspection method threshold, reducing false code, while maintaining the defect detection confidence. Further, very good. This is how AOI support continuous improvement, turning inspection data into actionable process intelligence. Today, I discussed briefly about the fundamentals. I didn't go in detail about the AOE and core technology behind that. Of course, in the coming session, we'll go through all those things. The next episode, we'll be discussing about how AO works and technology and capabilities. Of course, if you have any, I'm sure there will be doubts. There will be a lot of questions. You can directly raise your question in the YouTube, or you can write to me or Mr. Rajiv. We'll answer all your queries. Thank you very much.
That was a great presentation, Mr. Siraj, and thank you for presenting such informative presentation. It was great. And to all the audience out there, I know that there are couple of 2-3 questions in the YouTube, and also I have personally received 3-4 questions, which I will also integrate that into the YouTube comments. And thank you for joining and watching this show. And we will have an episode 2, 3, 4, 5 based on the AOI, as Mr. Siraj mentioned. The next will be how AOI works and the process and the technology on AOI, because AOI is a very, very important integral part of PCB assembly line. With that said, thank you, Mr. Siraj, for your valuable time for today, and have a wonderful weekend, and we will be in touch again in the coming days. And thank you all the audience out there for watching this show and supporting the channel. Please do subscribe to the channel so that you will get more notification on such important topics. Next week we'll bring another topic, a different topic of course, and please keep tuned with us. With that said, have a wonderful weekend, and wherever you are, please be safe and God bless you all. Thank you.
Thank you very much, Mr. Rajiv.
Thank you.
Bye.